Hello again, my little mathletes. It is Miss Jackson. We are working on subtracting rational numbers today. So we need to start by jotting down the process for subtracting fractions and decimals. So I'm going to take my paper, I'm going to split it right here for fractions and then split it for decimals. All right, so when we subtract fractions, we need to make sure we are finding the least common denominator first. Then we will subtract the numerator. After we subtract the numerators, we will keep the denominator the same and simplify. Okay, that is the same process that we use for adding fractions. The only difference is we added instead of subtracting. All right, so thinking about the process for subtracting decimals, we need to write our problem vertically. We need to line up the decimal points. And then we need to use placeholders if needed. And then after we have done all of that, then we can finally subtract. All right. When we subtract, we will be using the additive inverse to add the opposite. Remember, in your vocabulary, additive inverses are when you have a number and you add it to its opposite, the sum is 0. All right, then it says follow the rules for adding integers. Our rules for adding integers are going to be same sign. We add and keep the sign. If they have opposite signs, then we subtract and use absolute value. And I'm just put AV there, absolute value, to help us determine whether it's positive or negative. All right. We are going to look at one more thing real quick. When we talk about when we have subtraction problems, adding the additive inverse, I like to use KCC. Keep, change, change. That is your subtraction rule, how you change your subtraction problem to an addition problem. Hang with me. There is quite a few examples on here just because I want you to have adequate enough notes so that you can complete any assignment you need to. I do highly suggest that you watch the first one or two, then you pause your video, work the rest of them out in that section, and then replay the video so that you can see how I work them out. And then again, each section, watch me work one or two, pause the video, you work the rest, because that's how it would be if you were in class. All right, so the first thing here we have subtracting integers. That's our first section. We're going to rewrite the problem to add the opposite. Add the opposite, then follow the rules for adding integers. So again, we're going to be using keep, change, change. Oh. Keep, change, change. So we are taking our problem and we're going to keep 7, change it to addition, and then we're going to change the positive 16 to a negative 16. Once we use keep, change, change, then we have to look at whether it's same sign or opposite signs. This one is opposite signs, so we will be subtracting. 16 minus 7 is 9. The negative number has a greater absolute value, so my answer will be negative. All right, next one, negative 8 plus negative 11. Keep, change, change. Negative 19. Keep, change, change. Negative 15. Keep, change, change. We have opposite signs, so we subtract. It is negative because the negative number has the greater absolute value. Keep, change, change. We are subtracting again and keeping it negative because the negative number has a greater absolute value. All right, moving on to the next set of numbers. We're still using keep, change, change. Adding if they have the same signs. Subtracting if they have different signs. Writing our final answer. Keep, change, change. Again, keep the first number, change the sign to addition, and then change the sign of the second number. Keep, change, change. Once you have your problem, then you need to figure out if you are adding or subtracting. This has different signs, so we will be subtracting. So 15 minus 4 is 11, and then it's going to stay negative. Okay, that again should be a review for you from the past couple of weeks. All right, now we're looking at subtracting decimals. Again, we're going to rewrite the problem. So we are adding the opposite. Then follow the rules for adding rational numbers. We are going to keep, change, change. I'm going to go ahead and keep, change, change all of these at one time so that I can stack my decimals vertically to help me solve them. So again, I'm just going through the problems. I'm using keep, change, change so that I can stack them and work them out to ensure that I'm getting the right answer. And again, that process is just keep, change, change. Keep the first number, change the subtraction to addition, change the sign of the second number. All right, now I'm going to go through here and I'm going to decide whether I'm adding or subtracting. Again, same signs we add, opposite signs we subtract. So we'll be subtracting this problem. 6.3 minus 4.5 is 1.8, and it is negative because the negative number has a greater absolute value. We will be adding 2.9 and 1.6. So I get 4.5, and it again needs to go negative because a negative plus a negative is another negative. All right, we will be adding because they have same signs. 10.9, and it does need a negative sign because we add and keep the sign. All right, we will be subtracting on the next one. Lining up those decimals, bringing it down, and then distinguishing whether it is positive or negative. This one will be positive because the positive number had the greater absolute value. Circle. All right, last one for this row, we will be adding. This is where you need to make sure that you are lining up your decimals and not lining up the numbers. And then you are carrying what needs to be carried over, 14.4, and it will go negative. A negative plus a negative is a negative. All right, let's look at the bottom row here. We have two positive numbers that we're going to be adding together. Stack them vertically, lining up those decimals, and then you get an answer of 9.0. Or you could just write 9. And it is positive, because positive plus a positive is always going to be a positive. All right, we have 2 positives again, so I'm going to stack them vertically, lining up my decimals, and then I can add. My sign is positive, and I circle my ends. We'll go back and circle. All right, we have opposite signs, so we will be subtracting. Again, I'm lining up my decimal. I am borrowing what I need to. I get 1.8, and it needs to have a negative sign because my negative number has a greater absolute value. Scrolling over, opposite signs, we are subtracting. 11.8 minus 2.9. We will be borrowing. And then we have 10 minus 2 is 8. 8.9, and it will need to have a negative sign because the negative number has the greater absolute value in this situation. All right, the last one for subtracting decimals, we will be subtracting because we have opposite signs. Line them up vertically. Subtract. This is 1.1, and it does need a negative sign because the negative number has a greater absolute value. All right, so again, we did keep, change, change to change them from subtraction. I'm trying to zoom in just a little bit. We use keep, change, change to change them from subtraction to addition, and then we followed our integer rules for addition, and that was same sign add. And opposite signs, we are going to subtract. All right, so we're moving on to fractions. Your most favorite part of math class is fractions. I know. So much excitement. All right, so the process for fractions is the same. It just requires a few more steps. The last video, we talked about what those few more steps were, and one of those is going to be your least common denominator. So finding your least common denominator is another step that you don't have to do if you are working with decimals. And then simplifying is also something you don't have to do when you work with decimals, but does need to be done when you have fractions. All right, so we are going to rewrite the problem to add the opposite and follow the rules for adding. So same sign, add, opposite signs we subtract. All right, so the next 9 problems have common denominators. So we do not have to find the least common denominators. We'll just need to be adding the numerators and then going from there. All right, so we're going to rewrite these problems using keep, change, change. I'm going to change my color here. Keep, change, change. So I'll have 3/5 plus negative 4/5. And I'm going to go through the whole category and do this so that when I get ready to add, I can add. Again, that process is just keep the first number, change the subtraction to addition, and change the sign of the second number. So if it's positive, you'll change it to negative. If it is negative, you'll change it to positive. Keep, change, change. Keep the first number the same. Change it from subtraction to addition. Change the sign of the second number. All right, and as we move on to a new set of problems, I really hope that you will watch 1 or 2, pause your movie and then or video, and then work them out on your own. All right, so first one, we have opposite signs, so we're subtracting. 4 minus 3 is -1. And then we have over 5. So I'm going to rewrite my answer down here, -1 over 5. All right, we have same sign, so we are adding -6 over 6, which simplifies to be -1. All right, next one, -3 plus -5 is -8 over 4, which simplifies to be -2. And moving right along, we have -3 plus -9 is going to be -12 tenths. And that becomes -1 and 2 tenths, which is the same thing as -1 and 1/5. And like I've talked about on multiple videos, all three of those answers are correct. The most correct answer is -1 and 1/5. All right, next one, we have opposite signs, so we're going to subtract. 25 minus 17 is going to be -8 over 8, which is the same as -1. All righty, moving right along here, we have 4 more with like denominators. We have opposite signs, so we're going to subtract. -2, and then we have 2 minus 1 is 1 over 3. I will add a negative there, because my negative number has a greater absolute value. All right, here we are adding 2 positive numbers, so 7 plus 3 is 10, over our original denominator of 8. 8 goes into 10 one time, with 2 8s left over. 2 and 8 are both even numbers, so I know that I can simplify by dividing by 2. So I am going to keep my whole number. 2 divided by 2 is 1. 8 divided by 2 is 4. All right. Again, those two answers are correct. The most correct answer is going to be 1 and 1/4. Okay, next problem. I have 5/12 plus 1/12 is going to be 6/12, which is the same as 1/2. Positive plus positive is a positive. All right, very last problem with like denominators. I have -8/9 plus +4/9. -8 plus 4 have opposite signs, so we will be subtracting, and 8 minus 4 is 4 over 9. And then it needs a negative. 4 and 9 have no common factors, so it's going to stay -4/9, and it cannot be simplified. All right, so the biggest thing here is going to be rewriting using keep, change, change, and then using your integer addition rules. All right, subtracting fractions with unlike denominators. We need to find a common denominator. Rewrite the problem to add the opposite. So we're going to be using keep, change, change. Then follow the rules for addition. Same sign add, opposite sign subtract. All right, first things first, common denominator is 6. So I have -1 over 6 minus 4 over 6. Then I need to take the subtraction problem and rewrite it as an addition using keep, change, change. All right, I have 2 negatives that I'm going to add together, so my answer is going to be negative. I add the numerators. -1 plus -4 is -5. I keep my same denominator. I cannot simplify, so this problem is going to be -5 over 6. All right, next one, my common denominator here is 8. Zoom in a little bit. Multiply by 2, multiply by 2, and I'm going to rewrite the problem with my new denominators so that I can see it. All right, I want to go ahead and do keep, change, change here so that we will have an addition problem. So I keep 5/8. Going to do change the subtraction to addition, change the +6/8 to a -6/8. Since I have opposite signs, I will be subtracting, and 6 minus 5 is 1 over 8. The negative number in this case has a greater absolute value, so my answer will also need the negative symbol. All right, we are nearing the end, friends. So let's finish up strong. Again, I hope you are pausing your video, working these out, replaying the video to check your work. Let's look at -1 2/3. We need to go ahead and change that to an improper fraction where we multiply and then add and then put it over the same denominator. 3 times 1 is 3. 3 plus 2 is 5 over 3, and it is negative. Now I can rewrite my subtraction problem as an addition problem. Oh, but we forgot to find a common denominator. Shame, shame, shame. All right, common denominators here are 12, so I'm going to multiply by 4. I have 3/12 minus negative 20 twelfths. All right, now that I have that, we need to do keep, change, change. When we do keep, change, change, we're going to keep 3/12 the same, change the subtraction to addition, change the negative 20/12 to positive 20/12. Add my numerators, keep my same denominator, and then simplify. 12 goes into 23 one time, then I have 11/12 left over. And it does stay positive. All right. One last problem before we finish up with our notes. And that has a mixed number on it. So we need to go ahead and change that to an improper fraction. -3/2 minus -4/5. All right, common denominators between 2 and 5 are going to be 10. I'm going to go ahead and multiply. So this becomes -15 minus -8. And then I'm going to do keep, change, change. I keep the first fraction the same, change it from subtraction to addition, change the second negative fraction to a positive fraction. All right, I'm going to add numerators, -15 plus 8. They are opposite signs, so we can subtract. 15 minus 8 is 7/10. You do need to make sure that 7/10 is negative because the negative number in that problem has the greater absolute value. All right, I'm going to zoom out a little bit so you can see. That's quite a bit of work today on your notes, but like I said, I wanted to leave you with plenty of examples to make sure that we touched every type of problem and got an answer and some work down in your notes. All right, so the homework assignment is just like the one for adding rational numbers. We have the subtracting fractions, or I'm sorry, subtracting integers, subtracting decimals, the ones with like denominators, and then the ones with unlike denominators. Make sure that you are changing your mixed numbers to improper fractions and then looking for common denominators. We can go ahead and say the least common denominator on 13 is going to be 6. Least common denominator on 14 is 8. Least common denominator on 15 is 10. So I do want to help you out just a little bit. Take your time with this. Make sure that you are referring back to your notes and possibly the video if you need to. As always, comment on Google Classroom or send me an email and I will do my best to get back with you as soon as possible. But let me know what questions, concerns, struggles, anything that you have that we need to address. Please let me know. I hope all of you have a fantastic day and I will see you soon.